This is going to be the solution guide for the practice quiz. We're just going to kind of walk through these very quickly to help you understand better how to prepare for our quiz coming up on Monday. Our first one is an example of growth. I'm just going to put a G out to the side symbolizing growth. We know that it's growth because of the 3 is greater than 1. So my parent graph is going to be a basic growth function with a asymptote at 0. That asymptote is going to stay at 0 because there's no plus or minus out to the side, but the plus 1 right here is going to cause our graph to have a shift to the left of 1 unit. So my y-intercept is going to come to here, and it's going to come up, and my growth function is going to be like so. Let's take a look at number 2. On number 2, we have our normal growth function, which I'm going to draw in blue, just like we have in the past. And then we have 2 shifts. The first shift is going to have to do with a -1 right here, and that -1 is going to cause a shift to the right. -1 causes a right shift when it's inside. And then secondly, the +2 at the back is going to cause it to go up 2 to this spot. Now, that's also going to cause the asymptote to go up 2 as well. And so my asymptote is at the value y equals 2. And so in red, we have a growth function shifted over 1 to the right and up 2. Let's look at number 3. Once again, we have a growth function going up just like normal in blue. Let's highlight our important ideas. We have the -2. That's going to be a shift to the right 2. And then a -3 is going to be a shift down 3. Because we shifted down 3, our asymptote is going to go down 3 as well from 0. And our function is going to be a growth function going up to the right. Okay. So both of those were examples of shifting to the right on the second 2 and shifting to the left on the first one. Let's go down and look at number 4. Our original function is a growth function because it's 3 to the x, but because it's a negative, that -3 is going to cause it to flip over the x-axis. So everything that was a positive y is going to become a negative y. And so my y-intercept goes to -1. And it becomes that flipped growth function, but still with an asymptote of 0. Number 5, we have our normal growth function, but because it's flipped over the y-axis, I'm going to put that in purple. Here's our flip over the y, so here's our new parent function. And then finally we have a +2, which is a vertical shift up of 2. That means my asymptote also goes up by 2. And my function is going to be looking similar to the purple function, but up 2 units. Coming over here to number 6, once again we have our normal growth function. The -x inside for our exponent is going to cause it to flip over the y-axis in purple. And then finally, the +2 is going to cause that y-intercept to move up 2 units. As we've talked before, that means my asymptote is going to go up 2 units as well. So I'm going to mimic my purple graph, but I'm going to shift it up 2. So my final red graph is shifted up 2, but with an asymptote at y equals 2. Now, I just realized I do have a small error here. I made my asymptote at 1. So I'm going to erase that, put an asymptote in at 2. Just an example here of how it's good to talk through what you're doing and give the reasons, because that helps you make corrections if you need to. Let's come down here to number 7. My normal growth function, once again, is going up to the right. I have 2 functions going on here. The first one I'm going to deal with is the minus sign in front. That causes it to flip over the x-axis. Then I have the minus sign in the exponent. That's going to cause it to flip over the y-axis. So the purple flips over the y-axis. But we still have an asymptote at 0 because there was no plus or minus on the outside. In each case, the red graph is going to be my final graph. All right. We've got 2 to the x minus 3, all minus 1. So my original function is going to be a standard growth function. The minus 3 in our problem is going to cause it to shift to the right 3. So here it is shifting to the right 3. And then the minus 1 causes it to shift down 1. So my asymptote has shifted down 1. Final one is going to look like the purple, but with an asymptote at 1. Coming over here to number 9, we have a normal growth function once again. The minus 2 in the front of the exponent is going to bring it so it flips over the x-axis. So it's going to go down to the bottom. Then we have the minus x up here. That's going to cause it to flip over the x-axis, or excuse me, over the y-axis. So there's the flip over the y-axis. And then finally we have the plus 2. So it's going to go up 2. That's going to also shift our asymptote up 2. So my final graph is going to look like the green graph, except it's shifted up 2. Let's go down and look now at number 10. Number 10, we have a vertical shift going on, and the vertical shift would be called a stretch, and that stretch is a factor of 2. So our original y-intercept is 0, 1. Our new y-intercept is 1 times 2, or 0, 2. So our 0, 2 is our intercept. Our axis of symmetry is still x equals 0, and the reason is x equals 0 times 2 is still x equals 0. So we're just going to have a steeper shift here, but it's still got a y-intercept at 2. Here we have a growth function, 5 to the x. There we go, except now it's going to be multiplied by a 3. So 0, 1 for a y-intercept becomes 0, 3 because of the multiple of 3. So where we have our curve down, but we still have an asymptote at 0 because once again there's no plus or no minus. Our parent function is 3 to the x, something like so. We have a shift of 2 by a multiplier, and so that's going to come to our purple graph with the same asymptote as before. And then the minus 1 is going to pull that purple graph down 1 unit back down to the normal unit, but now our asymptote is going to be lower down at -1. Here's our first function that we have a decay function. So very quickly we have a decay function, just like so, with our asymptote at x-axis here, y equals 0. Once again, we have a decay function, normal decay function, asymptote at y equals 0 as a value. But we've got a number of 3 here, so my y-intercept of 0, 1 becomes a y-intercept of 0, 3 because we're going to multiply that by 3. But once again, we still have that asymptote at x equals 0, or y equals 0, excuse me. Our normal decay function, 1/2 to the x, is right there. Sorry about that for a sec, we'll pop that back. But we have a negative x in our exponent, and a negative x flips it over the y-axis. So everything flips symmetrically over the y-axis, but that's still going to give us an asymptote at 0. All right. Our next problem involves writing an exponential function in the form y equals a times b to the x. It includes the point 1, 6, and 218. So what we're going to do is we're going to start with plugging in the values y equals a times b to the x. And we're going to plug in the values 6 and 1. So 6 equals a times b to the 1, or 6 equals a times b, which means a equals 6 over b. There's our first equation. Our second equation is going to be 18 equals a times b squared, or 18 over b squared equals a. So there's our second equation. I'm going to set these equal to each other. I'm going to cross multiply 6b squared equals 18b. I'm going to divide both sides by b and get 6b equals 18, and divide by 6 and get b equals 3. I now take that value of b equals 3 and I'm going to plug it back in into 6 over 3 equals a, and realize that a equals 2. That gives me my equation of y equals 2 times 3 to the x. All right, our last two problems involve exponential regression, and we're going to use our calculator to do this. So before we start, we've got to isolate and figure out some values. So I'm just going to make an XY chart here, and we're going to try to determine some simple values of our problem. Our first value, I would say, is x equals 0 and y equals 5.1. My second value, I would say x equals 1 and y equals 1.7. X equals 2, I would say y equals 0.5. X equals 3, right here, just a little bit off. I'm going to say y equals 0.1. X equals 4, I'm going to say y equals 0.05. I know it looks like it's close, but I still don't feel like it's exactly touching, but I do feel like it's approaching the y-axis, or sorry, approaching the x-axis. So we're going to take these values, and now we're going to put all of these values into our calculator. So that's 5.1, 1.7, 0.5, 0.1, and 0.05 for 0 through 4. So let's go to our calculators, and let's take those and go into the stat mode, go into edit, and let's put these values in. So we're going to put in 0, we're going to put in 1, 2, 3, and 4. Now we're going to go back up to our first values, and we're going to put in our y values. 5.1, 1.7, 0.5, 0.1, and 0.05. These are our values for our x's and our y's. Now we're going to go to our window, and we're going to try to take our x from our min to our max. Well, 1 to 6 seems like a pretty good number. Then we're going to take a look at our y values. Our y values certainly don't need to go from 0 to 1250. Instead, I'm going to go from -1, because I feel like I'm getting very close to the x-axis, and I'm going to go up to 6 for my y's, and I'm going to have my scale be every 1. So there I have my window. Now I'm going to go to second stat plot. I'm going to make sure I turn my stat mode on. Then I'm going to come down, making sure I have all my colors appropriate. I think I'm going to go to red for this equation. That's going to be my equation there. The last thing I'm going to do is I'm going to take a look at what this looks like on my stat plot, just to make sure I have the right numbers. Looks pretty accurate, very similar to what I had before. And so now I can start my problem. Now you may see that the y is covering up one of our numbers there. If you don't like that, we can go back to window, and we can set our window perhaps to y max of 7 instead. Now when we click on the graph, you can see your first point up there at 5. Let's do our regression now, and go to stat, go over to calculate, go down to option 0, and I'm going to make sure I push my values into my y1 value by hitting alpha, trace, and push them into y1. And I'm going to go down to calculate, and that's going to give me my numbers. So my value of A, it looks like it is 5.2086, which that's going to be 5.209. And my B value is going to be 0.299 if I round to 3 decimals. So let's go back in and let's put those down for our answers. So my A value, once again, was 5.209. My B value is 0.299. Now I did round each of those, but that's okay, not a big deal there. Now we can go back to our graph, because realize we did push them into our y value. We go back to my graph, and we can take a look and see if my graph does go down. It seems like it does, and it seems like it's approaching. The last thing we're going to try to do is find the value for our function when it says predict the value at x equals 6. Now, I've shown you one way to do this before by going to second table and then arrowing down to 6, and it looks like the x value is 0.0037. Because it's so small decimals, I'm going to leave it at 0.0037, but I'd like to show you another way to go about doing this. If we go second quit here and go back to our normal screen, and then we go alpha trace, that brings up our y1 functions. Let's hit y1, and then let's go parentheses, and let's input the value 6. Now, you may not think this is very effective when it's only 6, but say it was 60 and you had an arrow down on that chart. You could easily put in any value for your function here and hit enter. And now you not only can get your answer, but you can get your answer much more accurately, reading 0.003699407. So I think that's going to be possibly a better method to finding our answers when we're trying to find other values. So my prediction of x equals 6, I'm going to say my prediction there is y equals 0.003699407. And I realize that normally we do 3 decimals, but I think this is much more accurate in this case because we worked it out using the function value instead of a table with limited decimal numbers. Let's take a look at our last problem down here, number 18. Our values on the bottom are 0, 2, 4, and 6, and on the vertical it looks like each of these tick marks represents 50. So we're going to have to do a little estimating here. If this is 50, then I'm going to have to say what is my value down here, and I'm going to say that value is 5. Then I'm looking here, if that's 50, I'm going to say this value is about 20. This value is 50 exactly. Coming up, 50, 100, 150 right here. So this value I look is between 100 and 50. I'm going to say that's 140. And then finally coming all the way up to the top, I'm all the way up almost at 200. This is 300. That's 350. So this value looks just shy of 400. We'll call it 390. And that's my final values there. So I've got my table, and I'm working through here. So I've got 5, 20, 50, 140, and 390. And those are values relating to 0, 1, 2, 3, and 4. So let's go down to our calculator, and let's plug these values in to our function. We're going to go once again to Stat. We're going to go to Edit. We have 1 through 4 again, but now on the right-hand side, we've got some different values. This is a growth function. Our first value is 5. Our second value is 140. Excuse me, our second value is 20. I'll clear that out. Our third value is 50. Our fourth value looks to be 140. And our fifth value is 390. This is obviously a growth function, so we can be expecting our b value to be greater. Let's go to our window. I think 0 to 6 is still a fine system there. However, on our y values, I'm going to go from 0 all the way up to 450. And I'm going to do like they did, and I'm going to put a tick mark every 50 units. Now we need to make sure our stat plot is turned on again, and it is, still as it was before, and we can take a look at our graph. And our graph looks very similar to what it did on our chart. Now let's go back to Stat. Let's go over to Calculate. Let's go down to option 0 for exponential regression, and let's push this equation, this time, into alpha trace, and I'm going to push this into y2 because I don't want to lose my other equation. I'm going to go down to calculate, and I'm going to calculate these values. Seems like here my A value is 5.7726. My B value is 2.9035. We're going to round those in just a second when we put them in on our button. But let's go up to the y equals. And now you see we have two equations in our problem. The first one is from our original equation, so I'm going to turn that off by hitting the enter button over the equal sign. And then I'm just going to focus on our second equation. So now let's take a look at the graph. Notice it mimics right through. We're in great shape there. But unfortunately, we have 1, 2, 3, 4, 5, 6. We need to make a prediction way up at the top for what the value is for 6 value. So, do you remember how that works? Well, let's do it. Alpha, calc. Now, we need y2 this time because that's what we're using. So y2 in parentheses, and we're going to put in the value 6. And let's make a high prediction. There we go. So the value is 3,458.975. So that's our value for our y. So now we can fill those in into our diagram. Our A value, as we said, was 5.773. Our B value was 2.904. And that's going to be predicting our value. Oh, and I was supposed to predict my value at x equals 5. So let's go back and do that. Apologize for that. One little trick you can do, you can arrow up twice. It brings back the former function. You can then edit that function. Maybe that's something you hadn't known before. Hit enter, and now we have the value at 5, 1,191.293. So there's our value. And we can go back and put that in to our problem. Our value is y equals 1,191.293. Now, your values might not be exactly the same based on what you chose for your values in your graph, but you should get something that's close as you're expecting that to work through. I hope this was helpful in explaining this practice quiz, and we're going to take a look on Monday at our actual quiz.